Okay, back at it again here. So tonight, gonna work on two kind of interesting items. The first is I want to instrument this GraphQL API here. I want to be able to see kind of the query and response timing. And in particular, I'm doing that because I'm starting to add in more caching. So I want to see at kind of a rough high level, what kind of queries are taking a while, and how caching affects and improves those. The other thing I'm going to show is how to use lazy initialization in Kotlin. So I have some files or kind of static data that are probably going to live in like CSV files or something like that. And I want to lazily initialize those and serve them up. And so Kotlin has a really nice and easy lazy initialization pattern built in. And we're going to take a look at how to do that and see what we can do there. So first, let's go ahead and start with instrumentation. So I want to get a better understanding of my query timing and how long queries are taking. And GraphQL, and in particular the GraphQL Java package, has essentially a built-in way to instrument the queries and the timing and kind of add data with the execution context and things like that. So there's an interface in here, and you can see it provides the ability to instrument execution steps of a GraphQL query. You might want to track which fields are taking the most time to fetch, log what fields are being asked for, things like that. So we can put together a version of this, and then we can go ahead and add our own instrumentation, however we might want to do that. So we will go ahead and put this here. Actually, we don't know necessarily how we're going to add it to it, but let's do query timing instrumentation. And I'll note too here, I'm just going to do like a simple custom implementation. There are implementations out there, for example, that do standard kind of open tracing versions of this, but I'm just going to kind of do a simple one because I don't necessarily care so much about all that. But so query timing instrumentation, I'm guessing there's so this is another thing. A lot of when you have, and here I'm going to look at this, when you have an interface like this that has a ton of different methods, and sometimes they're default and others are not. Oftentimes there's something called like simple, whatever interface in Java libraries, and this is actually the one that you want to extend because it has a base level of implementation, and then you can just override or add in the things that you need. In this case, it's just something that does nothing in all of the different different places, I'm guessing. But this is the one that we want to probably want to extend. So we're going to go ahead and do that. And let's take a look. Change constructor invocation. Okay. So let's take a look back at the instrumentation interface because I actually haven't done this. So let's take a look. So this will be called, so there's, we got to figure out what methods we need to implement, right? So this will be called just before execution to create an object that is given back to all instrumentation methods to allow them to have per execution request state. Okay, so this is our state object, right? So this is what we're gonna have to give back, right? So instrument query timing state. And let's call this var start, var end. So that'll be used for kind of the timing, and this is instrument state, so that can be passed along. All right, so we definitely need the create state method, and this is going to return a new query timing state object, and the start is going to be essentially the current what is it, system nano time. Is this safe? Yeah, precision but not resolution. Yep, okay. And then actually both of these are going to be, well, it always needs to have a start. So let's just put this in here as the default. All right, so that is the state that it's going to get, and this is going to start off as null. And then we're good. Okay, so we've created our state. And the parameters to this step. So I think we're fine there. Okay, so now there's a whole bunch of methods, and we just need to figure out which ones we want to do. So there's begin execution, validation, execute operation, strategy, fields. Okay, so I'm guessing we want, so I want like the whole time of everything. I don't necessarily care about super fine grain. So right at the start of query execution, it's the first step in the instrumentation chain. Okay, so here, this is actually where we would want to set the state. So we can't do it there, but we can do it in begin execution. Okay. And so, yeah, we're going to return that, and instrumentation. So parameters dot, and I'm guessing, oh, where does our state come from? Parameters that get, yeah, there we go. Okay. Val state, and this is query timing state. And then this is, so we need to say it dot start equals system dot nanotime. There we go. Okay, so on begin execution, we start the time, and then I'm guessing there's an end execution. Instrument. So there's begin, and then there's instrument. So that's probably, this is called to allow instrument just before it's used to fetch a field, before it's used to execute a query, before it's used to parse. Okay, so this is called to allow instrumentation to instrument the execution result in some way. Okay, so that's probably what we want. Instrument execution results. There we go. Okay, so we're gonna do the same thing. We're gonna grab the state. We are gonna say end equals system.nanotime. Okay, so here, what do we want to do? We could certainly log. I mean, that's at least a good thing to do. Well, we'll just, for now, we will just log to make sure that we have the right implementation. Oops. So first we'll log query timing of that. So I'm going to say query took that, and so this is going to be execution result dot, oh no, that's the result. So parameters dot query, and then we need the time that it took. So this is val time equals state dot end minus start. Smartcast the line possibly because that is immutable. Oh. Actually, this isn't really that useful. Really what this is like a late init. Yeah, really that's what we want. But we can't do that on that. This is probably easier. I'm gonna do this. Okay. Those don't need that anymore. I always get this wrong. Because I don't like to use let. But this is going to be, there should always be parameters. Yeah, this is, I think, just weirdness with the Java to, so sometimes when you're using like Java libraries that aren't necessarily annotated with nullable information, Kotlin has to assume that they're non-null, so you get weird stuff like this. But you're usually safe to remove that. Okay, so that's this, and then basically, if you're not familiar with the Java time unit for converting seconds to all sorts of different things, you can do time unit dot whatever unit, so milliseconds, nanoseconds, whatever, and then you can say two milliseconds of this duration. So this is super handy. I see people all the time in Java and other languages or in Java and Kotlin, kind of like doing the manual math or like making a constant of how many seconds there are in a minute or hour or whatever. Like Java has this built in, it's time unit. I feel like this is like a not often or not well known API, but it's super handy. So, you know, again, we're saying we're taking a unit that is in nanoseconds and converting it to milliseconds. So, okay, so let's go ahead and run this. Well, okay, so hang on. We created this. We need to wire it in. So we need to add it here. Query timing instrumentation. An instance of that. Okay. And let's just creating timing state. We're just going to put some stuff in here just so that we can trace the execution. The beginning timing state. That should be good. So let's go ahead and run this and see what we get. And let's do it on a query that takes a lot of takes time, and that is certainly the portfolio with positions and all of the values and everything. I got a new oh man, that query is gnarly. Okay, so what's a better way to what else is on parameters in terms of like operations? Probably better, not the query, because the query is like the whole thing. That's what all that mess is. That's what all that mess is there. So it's not going to be very readable or usable. Okay, let's go ahead and run this. Okay, so creating timing state, beginning timing state, getting portfolio with positions, did all of our stuff, got the quotes, saved the quotes, and the query took 5233, so almost 5 seconds. So that's quite a lot. But remember, in the previous stream, we added caching. So this next run through should work a lot faster. However, I'm going to debug this real quick because I want to see what's in these parameters so that I can find something that's like useful. I don't think there's going to be anything useful in here, which is tough. Although if we change our query up a little bit, we'll get the operation name, I think. But we should see that query went a lot faster. Yeah, okay, so this is, again, importance of caching, right? Previous query that took nearly 5.5 seconds is much faster with caching in place. So again, caching makes a huge difference, and we'll continue to use this and work on this and make this better. But let's figure out how we can kind of trace and track what's going on here. So you can name your queries. Yep, there you go. So you can with GraphQL, you can like do what's called a named query. So this is a way to identify what query you're running. So in this case, I'm just saying all portfolios with positions, I don't say with change, right? So now when it's logging, I actually see what's going on. So okay, so this is what we want. This works. We can get rid of the timing logging. And so now we have some instrumentation. So we can now start to understand and get at least some basic information about what is happening with our queries, which is great. So what else? Format, arguments, yep. All right, so that's query timing. And again, this instrumentation interface is really powerful. You have ways to hook into all sorts of different things, parsing and validation, how it's executed. You can look at specific fields, right? So for example, if I wanted to look at, remember in the previous stream, we looked at kind of an expensive field to calculate, which was this change object. We could basically wrap timing around just the change object to see how long this thing is actually taking. So you can get down on like a per field level and to say like, hey, if this field is different, or this field, you know, if all these fields don't come from the same place, you know, tell me more about how long it takes to get this field. So actually, let's go ahead and do that. I don't know if it's really worth it, because really what I care about is like the full, that full thing, right? Well, actually, let's, if we comment these out, the query should be a lot faster. Let's just check that out. About a second, yeah. And that's without caching, or no, that was with caching, right? And then we get 938 milliseconds. Okay, cool. So we have query timing, which is great. Now, let's turn to the other thing I want to look at, which is lazy initialization in Kotlin. And this is an interesting one. So here's my use case. I have some data that lives in the resources folder. And basically, it's a list of companies, and their, well, in particular, their stock symbols, stock ticker symbols. And these companies are a part of these kind of lists or groups called the dividend aristocrats and the kings. And what these are is basically groupings of companies that have paid dividends for a certain amount of time and have also continually increased their dividends. So these are, you know, by and large, very safe, you know, large established companies that have, you know, a long history and record of giving money back to their shareholders if you own their stock. And for people who are interested in dividend investing, these lists are helpful and useful. And so I want to be able to query those from the API and be able to show those and allow people to use those and research those companies in the app. And I want to only load these up into memory when they're actually queried for. And then once they're in memory, I want to keep them in memory and cache them. So we're going to go ahead and take a look at that. And we're going to look at Kotlin's way, or built-in way, or one way to do lazy initialization. And some of the interesting pieces around that API, because I think it's pretty useful to look at. We'll also probably get into some stuff with Kotlin in terms of file I/O. So Kotlin has some useful extension functions for doing file I/O. So let's go ahead and see if we can find what to do here. Okay. So we have this file, dividend companies, and what we're going to do is we're going to just put a class together that can grab these things, dividend companies, and return those items. So the first thing we're going to need is the resource loader from Micronaut. So this is basically a way to load things in. Resource loader, file system resource loader. What is special about this thing? I don't know, I'm just going to use resource loader because that's really the one that I'm familiar with. Resource loader. So this is for grabbing resources, obviously. So now let's get into Kotlin lazy initialization. So as I said, Kotlin actually has a lazy keyword built in. And so let's take a look at how to use it. So we have a file, dividend aristocrat. So we're going to create a property here. It is, well, actually first, let's also create a, there's a data class that I've created called dividend company. Well, it's the list, right? And so we're basically saying, hey, you can get a list of these things. And then in order to do lazy initialization, you say by lazy, and you give it a block. Okay, so let's take a look at this lazy keyword because there's a couple of interesting things in here that we're going to use. So what does this do? So it creates a new instance of the thing that uses the specified initialization function and the default thread safety mode. If the initialization of a value throws an exception, it will attempt to reinitialize the value at x-axis. So this is super useful because if we have trouble loading the file or anything like that, we can just throw an error. And obviously it's not going to be there for the person that tried to access, but if they try to access it again, it will actually load. So this comes in super handy, and we're gonna use this feature of the lazy keyword. So we need to load a file, and we need to load a file from resources. And we're going to need to specify the type, right? Because we're going to have aristocrats and kings, and then we're going to need to specify the file or the name of the file, right? And this is going to return dividend company list. And I'm just going to return, we're going to say load file. The type is aristocrats, tough word to type. And the file name is dividend aristocrats.txt, right? Okay, so let's load this file. So now let's talk a little bit about Kotlin Io. So Kotlin has a bunch of useful extension functions for doing I/O. And we're going to use these when we're loading up this file. So first thing we're going to do is get the stream using the resource loader. So we need a stream to the file. So the resource loader dot get resources stream, and we want the file. Why is this complaining? Property getter or setter expected. Oh, fun. It's a function. We want a file. Then, if the stream is present, we're going to do something with it. Otherwise, we're just going to throw an exception saying unable to find file. Unable to find file. So again, if this happens, this will continue to reevaluate every time someone accesses it, and we're going to see a whole bunch of these things in the logs. Now, if the stream is present, this is where we can start to use the helpful kind of nature of this. So let's take a quick look. So the dividend company list, I expect to take in a type, so like aristocrats or kings or whatever, when it was last updated, and the symbols. This could probably be an enum, but we'll do that later. So it takes in these things. So we need to create those things. So we're going to need, the date. This is going to change. We're then also going to need symbols, and this is going to be a mutable list because we're going to add to it as we go through. Mutable list of, yep. All right, so we have a stream, and many of you who maybe aren't necessarily more familiar with Kotlin might do, your typical try catch with resources, things like that. Kotlin has some handy extension functions so that you don't have to do that, and kind of all of that stuff is taken care of for you, and it will rethrow the exception, which is exactly what we want. And that is the use keyword. And so actually this is an optional, so we need to do stream.use. And you can, if you do that, you can just pass in a block, but we're actually going to call, we're going to call use, and this is going to be the input. So now, we have an input stream. Okay, and so let's take a look at use. So use inline function executes the given block function on the resource and then closes it down correctly whether an exception is thrown or not. So again, right, it's just shorthand for try catch finally, which is awesome. So and like I said before, it rethrows the exception so that thing bubbles up. So if anything happens while we're trying to read that file, it bubbles up, throws, the lazy fails, but then the next time someone calls this, it will try and reload it. So exactly what we want. So we have an input stream, and so we want input, and then we want a buffered reader from that, right? So again, another handy Kotlin extension function that creates a reader from that input stream. And then we are going to read lines. And we are going to do for each indexed line, and we'll read this. So if you take a quick back look at the file I have, first line is the date, and then the rest of the lines are the symbols. So we can say if the line equals that, then basically the date equals the line, else symbols dot add the line. Okay, and then at the end of this, we need to return our dividend company list, which takes in a type, which is essentially the type that was passed in. The last updated, which is the date that we captured, and the symbols, which is the symbols that we captured. Okay. And so we can reuse this and load both of our files and see what we get. Does that look right? Yeah, load files. Yep, that should do. All right, and I've already created, I was kind of working front to back earlier, so I've already created the queries for this, I believe. Yeah, and it just calls, dividend companies.aristocrats and kings. All right, so let's give this a shot. And we will, as always, use our trusty logger. To tell us if what we're doing is right. Init aristocrats. So we should only see this init for each of these once. And then it should retry again. So let's see what we get here. Let's do a new tab. Okay, query is dividend companies. We're going to ask for aristocrats, and we're going to ask for the symbols and the last updated, and we're going to ask for kings, symbols, last updated. All right, let's see if that works. Okay, so we can see getting dividend aristocrats. We can see init for them. We can see init for kings. Okay, so now if we rerun these again, we shouldn't see any init because basically those items were lazily evaluated, stored in these variables, and right, yeah, we don't see that anymore. So we'll see, you know, took 2 milliseconds, which is great. Cool. So again, this is lazy initialization in Kotlin, or a way to do it in Kotlin. It's a built-in keyword, and it operates by basically you giving it a block, returning the thing that you want to lazily evaluate. And if you throw an exception when you're trying to initialize that, it will reevaluate the next time and try to actually load it. So it's always eagerly trying to load, it's always lazily trying to load what you have in the block. But if anything goes wrong, it's always trying to actually give the variable a value. And actually, do we need this here? Yeah, this would actually be better. Well, no, we don't. It could be no, because if it fails, it will return null. So that's probably semantically the better thing to do. Right. So yeah, so that's lazy initialization. Let's take a look back at our. Oops, I don't know what that is. Yeah. I have another idea. Let's take a look back at our query timing. And one thing that might be useful is putting the query timing in the extensions block for when queries return. That way the client can then also help us potentially instrument things as well. Let me think about how that might work. We have an execution result there. Yeah, extensions, interesting. Okay, so a lot of times if you've ever instrumented an API before, you might send the query timing or send information back to the client in the headers. And GraphQL has this thing called extensions where you can essentially put arbitrary data. So I'm going to put the timing into the extensions so that the client can see it. So let's do that. So execution result. So timing equals map of, we're going to call this query time to time unit dot nanoseconds dot 2 millis. Always give it a unit, and dot extensions dot, I'm gonna put rather than create this, I'm gonna put, because there might be other things in it. I guess it doesn't like that, huh? Key value. Yeah, there we go. Likes that better. Or yeah, it's gonna ask me to convert it to that syntax. Okay, that's fine. So now when we run our query, let's go back to our bigger query here. I think we should see oh yeah, extensions must not be null. Okay, so if execution result dot extensions is null, we need to initialize it. Equals mutable map of, oh, but it's a val. Ooh. Returns a map of extensions or null if there are one. Okay, so we have to well, okay. Maybe that's just for the initial query that GraphQL is hitting it with here. Let's run this and see what happens with ours. I don't know if we might have to like duplicate or recreate the extensions. Okay, let's GraphQL extensions. We might need to look at the spec. Maybe this isn't really the best way to do this. Writing and consuming extension is to pass information to extension consumer in order to extend the behavior of GraphQL's fidge logic. Right. Is this in the I don't know if this is the GraphQL spec or if this is the Apollo spec. I don't remember. Query, mutation, subscription. Yeah. Extensions. Type system extensions, scalar extensions. Okay, so maybe this is an Apollo thing? I know this is where you're supposed to put errors. So, because like if you look here, it's supposed to go in extensions, right? Huh. In the okay. So yeah. So what do we need to do? Create a new instrumentation result? Hang on, let's take a look at this. This is a little weird. So the execution result is created. The extensions are null, probably because there's data in it. But that unfortunately is a val. Execution result impl. Yeah, okay, we have to just create another one. Yeah, I think we just have to wrap it and create another one. Okay. So if it's null, then we do the result is execution result. Oh, is this protected? No, it's public. Oh, but it's internal. Oh, really? Oh, but the interface isn't. Yeah, the interface is public API. Okay. No, but I should still be able to use that. Okay. So what is this complaining about? None of the following. Okay. Oh, there's a builder. Oh, yeah, there's a builder. Okay. That's why. Execution result impl dot builder dot. So we give it the one that we've got, and then we add extension, which is a val extensions equals a map of this to this, and we're going to give it extensions. And why are you complaining? Builder dot from an execution result. Add extension string. Oh, query time ms, and add this in here. And then we want to return super.instrument execution result. Give it the new result. But we got to build it. New result, and then we get. Okay, so now we're good to go. This, I don't know if this is really internal or not, but this should be okay. It's not a big deal. So now if we run this, we should get our timing, maybe not. We should get extensions. Why don't we get extensions? Do we have to say that we get it back? That's kind of interesting. requests and responses. How to enable and configuring options for extensions. Successful queries will return data and extensions. Yeah. So, and we'll include JSON keys for data, errors, or extensions. Errors field, the extensions field contains extra metadata, yeah, for request tracing and yada. Yep. Okay. Yeah, so tracing in the Apollo tracing format. Extensions are returned in every response. These are completely optional. If you want to turn them off, okay, so this is dgraph. Maybe GraphQL Java extensions. Maybe they're turned off in GraphQL Java? That doesn't make sense because they come back in errors for sure. You have to do that? No? Interesting. Why isn't this coming back? Oh, did we not rerun our server? Let's make sure we're getting hit here. We are not. Okay, well that time there were extensions. What the heck? Oh. That is the problem. One character. All right, so now we should be seeing extensions. Yeah, there we go. Okay, so now we got query time in milliseconds. Okay, cool. So that's so now our client is aware of the query timing, so it can use that and log that. And so just to come back to this quickly, right? Apollo has a specific tracing format, and this works automatically, and it's available in GraphQL Java. So if you want to add it, you just have to add the class, which there's gotta be a, yeah, I think it's called tracing support, right? Yeah. So if we didn't want to use ours, we could, well, actually we can add multiple, right? So let's do this tracing support. Rerun this. Actually, what? Implementation state. This is a stateful object and called via instrumentation. Oh, so you just put this in existing code. Oh, that's kind of fun. Okay, so we can literally add this to our existing thingamabob. So we'll just add it here, and then create this bad boy. What does this take in? Include trivial data fetchers. False. Okay, and then so I assume you just do, okay, yeah, so then we're just gonna do like, I assume you just do state dot tracing support dot begin, right? But okay, so it probably doesn't have all of the methods. Begin field. Right. Okay, so this doesn't do the same stuff, but if we did begin field, so we would do this. Again, remove this. You know, we'd call that method with the data fetching environment. How does this thing work? I assume you just drop it into. Oh, there is a tracing. Yeah. Okay. Yeah. Yep. I just missed this earlier. So we don't need this. There's an actual instrumentation class. So you can also, and again, you can add multiple. This is a builder, so you can add multiple tracing classes. So we'll add that one in. And so in addition to what we have in our extensions, we should see the Apollo stuff as well, which we do. So we'll see a whole bunch of stuff in addition to, oh, it doesn't have ours. Oh, you know what? It's because we didn't add ours. Query time ms time unit dot. Yeah, so now ours will show up. But you can see here that the tracing here is way more granular. So, you know, this has at all of the different levels, the different objects, and all that kind of stuff. This is really overkill. It's really great if you have it and you want it, but this is way too much for me. So I'm more curious about the entire time. If you want to get deeper, you can add that in because it'll literally do everything everything by field. So so yeah. So I think that's about where we're gonna wrap up tonight. We accomplished everything I wanted to do. So you know, again, we took a look tonight at instrumenting your GraphQL queries, adding custom instrumentation, and we're tracking now query time, so I can kind of keep an eye on those. We're going to use those in a future stream to kind of help understand query performance at a, you know, again, at a broader level, and then try to add some caching in places to see if we can make that better. Then we took a look at lazy initialization, which is a pretty cool thing in Kotlin. You know, it has some built-in operators and primitives to help you do that, so you don't have to roll your own like you would in Java, and has some interesting, you know, properties in terms of it throwing if you throw an exception, it reevaluates. So that's it for tonight. We will see you hopefully in the next stream.